Yes, we have refrigeration under materials because we are going to worry about replacing the harmful refrigerant materials with natural ones or environmentally friendly ones. And this is ranked by 2050 at number 1. Yes, 89.74 gigatons in reduced CO2, but the data is too variable to be determined in terms of net costs, whereas the net savings are a minus 902.8 billion, so that's not just a saving, it's a net profit. Sherwood Rowland and Mario Molina won the Nobel Prize in 1995 for discovering the role of CFCs or chlorofluorocarbon gases in harming the ozone layer, which everybody's heard of, I think, by now. That they obviously showed that the CFCs off-gassing chlorine atoms destroy atmospheric ozone, and it has a bad impact for all life forms. And Montreal Protocol on substances that deplete the ozone layer came from their work banning CFCs. Ultimately, 197 nations have adopted the 2016 Kigali Amendment to the Montreal Protocol, an agreement to phase out hydrofluorocarbons by 2028. So, as opposed to solving the climate change problem, solving the CFC problem was a bit more straightforward because there was a solution, HFCs, available at the time, and CFC's ozone hole damage was going to hurt all life forms. So, obviously, climate change doesn't have one silver bullet solution, but anyways, HFCs then turned out to be okay for ozone hole, but they ended up being really bad for global warming in terms of their impact on the greenhouse effect. So HFCs not only erode the ozone layer, they also are one of the most potent greenhouse gases known to humankind. This is from downtown Singapore, showing the ubiquity of air conditioning units on Asian streets. Singapore is a small, rich country, and of course it's always hot and humid, but even countries like India and China are getting hotter, and people are growing in terms of per capita GDP. Economy is growing, so obviously the demand for air conditioning is going to keep growing, and refrigeration, which is now a necessity in rich countries, is also becoming more and more so in the developing world, which means the demand for air conditioning and refrigeration is going to keep growing, which is not good news for global warming unless HFCs are replaced, right? Looking at energy forecasts from 2010 to 2030, the energy demand for networks, so ICT is information and communication technology, consumer devices and data centers, which are the new beasts, are going to keep demanding more and more energy. And you can see the trend going from 2015 to 2030 projections. You want things like internet explosion. You want everybody to have access to the internet. It's the democratization of information access. Often it is argued that poverty is not just lack of money, but it's also lack of information. So that's adding to the demand. And growth in data centers. All these big giants like Facebook, Amazon, Google, and Microsoft want to save everything for you, and people love saving everything, including emails, photos, etc. And you can see that traditional data centers have shrunk from 2014 to 2020, whereas cloud data centers, non-hyperscale and hyperscale data centers, which are apparently efficient, have grown as well. In terms of their energy demand, going to 200 terawatts a year. Looking at their demand for renewable energy, all of these big giants are also announcing that they will do better business by growing their renewable energy portfolio as well as going carbon neutral. So you can see ICT and other, in terms of energy demand from 2010 to 2016, there is a massive growth as well. So we are doing unintentional things also by demanding that our data be saved. Energy scale. Global electricity demand is at 20,000 tera-hours. Electricity used by ICT, which is now ubiquitous, especially with IoT, which is supposed to make more efficient energy use in some quarters, but also increase energy use in other quarters, is going to be 2,000 terawatt-hours. Data center electricity demand is at 200 terawatt-hours, and Bitcoin use by mid-2018 was already at 20 terawatt-hours. These keep cranking away to maintain this Bitcoin and cryptocurrency business, and there are more and more in the market now, and people are investing more and more in those. Just how bad are HFCs? If you look at indirect effect in terms of energy use, that's at 80%, and direct effect in terms of refrigerant emissions is at 20%. So the reducing indirect impact due to energy consumption is the highest priority for management of refrigeration systems. It's argued that HFCs have a low impact on climate, because if you just look at their values of global warming potential after 100 years, carbon dioxide is at 1, but its lifetime matters as well. So we have to worry about residence time, concentration, and global warming potential, right? So there is methane, nitrous oxide, and other ozone depleting substances. HFCs, PFCs, and sulfur hexafluoride are here. So the refrigerants have a massive global warming potential, but if you look at the quantity, obviously CO2, methane, N2O, and ODS dominate, whereas HFCs and PFCs are down here. So overall, their impact is more on the energy use in refrigeration and cooling, which includes all these food supply system as well, going from shipping, cold storage, transport, distribution hubs, supermarkets, restaurants, and households. And the good news is that if you look at the global warming potential weighted production of CFCs, HCFCs, hydrochlorofluorocarbons and hydrofluorocarbons, they have decreased by 90% from 1988 to 2005. So there is a massive drop, so that's good news as well. And there are better natural refrigerants around now. So if you compare the global warming potential of fluorinated gases and natural refrigerants, again, so there are CFC 11 and 12 which are not completely gone yet, and there are HCFCs and HFCs over lifetime, 20 years, 100 years, and 500 years. So their lifetime is 45 to 100 years here, 9.3 to 14 years here, and their global warming potential drops over time, whereas CO2 remains the same. So CO2 having a multi-century residence time has to be really something we have to worry about. And natural refrigerants like cyclopentane, isobutane, and propane last only weeks to months and have a low global warming potential as well. Okay, so we need to worry about the proper items when it comes to refrigeration and cooling. Our analysis includes emissions reductions that will be achieved through 2016 Kigali Amendment or Kigali Accord, as well as additional practices to manage refrigerants already in circulation. Phasing them out will be difficult because new HFCs keep getting manufactured and emitted. We model adoption of practices to avoid leaks from refrigerants, destroy refrigerants at end of life. Over 30 years, 87% of refrigerants that may be released can be contained, avoiding emissions equivalent to 89.7 gigatons of carbon dioxide. Although some revenues can be generated from resale of recovered refrigerant gases, the costs to establish and operate recovery, destruction, and leak avoidance outweigh the financial benefit. So it's a co-benefit that we have to worry about. meaning that refrigeration as modeled could incur a net cost of 903 billion by 2050. This is why it sits at number 1 in drawdown, because it is something that's going to become more and more common, and it's a simple adaptation to climate change. If it's warming, you get an air conditioner, right? But if air conditioner is not friendly to the environment, then you are not accomplishing much. Plus, refrigeration is going to become a necessity as the world warms, especially in the global south, the tropical countries. So this is why this is a no regret solution at number 1.